number systems, and base conversion. Okay, what is number systems? In our life, we learned from our from the beginning that the numbers is start from 0 and it has 10 digits, 0 up to 9, and we always use base 10 system to describe or represent a number. But base 10, which we use in our life, it's not the only number systems that are available. We have different systems to representing the number of objects or the number in like in computer science and mathematics. So in general, we have a definition. We have a definition for any number system. We say that in fixed point, fixed point base R, base R number system, a number is written as the number is n and in base R. What we like use in our life is base 10. So R is the 10 in our like daily life, but in our life, but in any other bases, we can represent the numbers. So a number in base R is written as follows: a sub n minus 1 up to a1, a0 dot a minus 1, a minus 2 up to a minus m in base R. So this one is the general form of any number in base R. Okay, let's see what components we have in this system. The first thing we should know that before this radix point, this point, we call it the radix point. Radix point. Left side of the radix point, we call it in like integer part. And right side of the radix point is a fraction part. Okay. A sub n, which is here in the integer part, is the most significant bit or we can show it with MSB, most significant bit, and A sub minus n is least significant bit, least significant bit, or LSB. Okay, we should know that A sub I, any like of these A's that we have here should be equal greater than 0 and equal less than r minus 1. So if we're talking about base 10, any of those digits can be between 0 and 10 minus 1, which is 9. Okay, we already know that in base 10, we have the digits from 0 to 9. We don't have a digit 10. Okay, so for any digit, for any base, we have digits limited between 0 and r minus 1. For example, also we can call these digits coefficient values. Coefficient values. So these coefficient values, as I said, are limited. For example, for base 5, if we are in base 5, the coefficient values are 0, 1, 2, 3, and 4. So these are the coefficient values of base 5. Okay, so base 2, of course, base 2 has the coefficient values of 0 and 1, and which is base 2 is the most important base in computer language and computer engineering, and we call it the binary system. Binary system. In general, a number expressed in base R, okay, base R has coefficients multiplied by powers of R in order to convert them to base 10. So we can simply convert any number in any base to base 10 by considering the power of R's for each coefficient. So let me write it here. In general, a number expressed in base R has coefficients multiplied by powers of R in order to convert them to base 10. Okay, so let's see. If we have this number in base R, let's say we have a sub n minus 1 up to a1, a0 radix point, a minus 1, a minus 2, a minus m. And if we want to convert this number in base R to base 10, what should we do? We need to multiply each coefficient by power of R. So it's like we multiply a sub n with R to the power of n. We multiply a sub n minus 1 by R to the power of n minus 1, and R to the power of 1, R to the power of 0, R to the power of minus 1, R to the power of minus 2, and finally R to the power of minus m. And so the base 10 equivalent of this number will be a sub n times r to the power of n plus a sub n minus 1 times r to the power of n minus 1 plus, we continue until a sub 1 times r to the power of 1 plus a 0 plus a minus 1 times r to the minus 1 plus a minus 2 r to the minus 2 plus a sub minus m times r to the minus m. So this one is like the conversion of the number in base r to base 10, okay? So this number is in base 10. When we put the number in like any bases, we can put the number in the parentheses and write the base in a subscript like 10, and r here shows the base of each number. Okay. Let's see one example. Example, we have this number 4021.2 in base 5, and we want to convert it to base 10, okay? The thing that we should notice here is that none of these coefficients are equal or greater than 5 because the number is in base 5, so all the coefficients should be less than equal to 5. Okay, we want to convert this number in base from base 5 to base 10. What we can do, we know that this one is r to the power of 0, r to the power of 1, r to the power of 2, and r to the power of 3. What is r? Of course, r here is the base, which is 5. And for this point 2, r to the power of minus 1. So let's use this equation to convert this number from base 5 to base 10. Okay, let's do it together. We say 4 times 5 to the power of 3 plus 0 times 5 to the power of 2 plus, let's put these numbers in the parentheses, okay, plus 2 times 5 to the power of 1 plus 1 times 5 to the power of 0 plus 2 times 5 to the power of minus 1, which is equal to 5 to the power of 3 is 125 times 4 is 500 plus 0 times 5 to the power of 2 is 0 plus 2 times 5 to the power of 1 is 10 plus 1 times 5 to the power of 0 is 1 plus, and 2 times 5 to the power of minus 1. 5 to the power of minus 1 is 1 over 5, so it will be 2 over 5, which is equal to 511.4 in base 10. We converted the number from base 10, from base 5 to base 10. The next example, let's convert 127.4 from base 8 to base 10. Okay, I want you to pause the video here and do it yourself. After you finish, you got the result. You can play the video to see if answer your answer is correct or not. Okay, now that you solved this problem yourself, let's just see how did you do in finding the base 10 equivalent of this number in base 8. So we say 1 times 8 to the power of 2 plus 2 times 8 to the power of 1 plus 7 times 8 to the power of 0 plus 4 times 8 to the power of minus 1, which is equal to 87.5 power of 10. Okay. Sometimes we Okay, so if we have any base less than 10, everything is fine. We have no problem to assigning the coefficients because we already have the coefficients for base 10 from 0 to 9. So if we're talking about base 4, we know that the coefficients are 0, 1, 2, 3. If we want to work in base 9, the coefficients are 0, 1, 2, 3, 4, 5, 6, 7, 8. But what if the base is greater than 10? Okay, so what if the base is 16? So if we start using the coefficients from 0 to 9, so what is the next coefficient? Because we don't have any coefficients defined for the numbers greater than 9 in base 10. So here we use letters, okay, alphabet letters to assign for the coefficients greater than 10. So if we talk about base 11, so the coefficients are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A. So A is the last coefficient. One of the main and important bases which are very useful in computer science and engineering is base 16, which is called hexadecimal base. So we need to find and assign coefficients for this base and learn this base as well, and know how to convert this base to other bases. So let me just write it down what I mentioned. The letters of alphabet are used to supplement the 10 decimal digits when the base of the number is greater than 10. Okay, here we want to introduce hexadecimal base 16. So base hexadecimal. In base 16, letters A, B, C, D, E, and F are used for digits 10, 11, 12, 13, 14, and 15. Okay, so in base 16, instead of 10, because we cannot use 10 as a digit because it still consists of 2 digits. So instead of a 10, we use A. Instead of 15, we use F. Okay, so we use these letters to represent the coefficients in base 16. Here is an example. In base 16, we have this number B 6, 5, F in base 16. We want to convert it to base 10. Okay, so we say instead of D, so D is like representing 11. So we say 11 times 16 to the power of 3 plus 6 times 16 to the power of 2 plus 5 times 16 to the power of 1 plus F. F is representing number 15. So we say 15 times 16 to the power of 0. This number is 46,687 in base 10. Okay, so we converted BF B65F from base 16 to base 10. As you notice, the numbers in base 16 are more complex than numbers in base 10 because we have more digits. Okay, now what about other conversions? So far, we learned how to convert numbers from any base to base 10. What if we want to convert the numbers from base 10 to other bases? Okay, conversion between different bases. We discussed the conversion from base 10 to other bases first. For converting from base 10 to other bases, we need to do that separately for integer and fraction parts. And there are two methods to convert an integer number from base 10 to base 2, which are, okay, so for this, for now, we will talk about conversion from base 10 from base 10 to the other bases. Okay, so and also I said we need to do it separately for integer part and fraction part. So first, let's talk about integer numbers. We have two methods. One is subtraction method, and the second one is division method. In this lecture, we will talk about second method, which is division method. So, how we can convert integer numbers from base 10 to other bases. We see it with some examples. We want to convert 156 from base 10 to base 2. How we can do this? By dividing 156 by 2. So we say 156 divided by 2 is 78. The remainder is 0. 78 divided by 2 is 39. The remainder is 0. 39 divided by 2 is 19. The remainder is 1. 19 divided by 2 is 9. The remainder is 1. 9 divided by 2, 9 divided by 2 is 4. Remainder is 1. 4 divided by 2 is 2. Remainder is 0. 2 divided by 2 is 1, and the remainder is 0. And we have 1, which is less than 2. And we get these numbers, these reminders. Bottom up way, from the bottom to the up. And this one is the answer. So the answer is 1 0 1 0 0 1 1 1 0 0 in base 2. So 156 in base 10 is 100111100 in base 2. Okay, the next example, we want to convert 3875 from base 10 to base 16. Okay, please pause the video and do it yourself, and then compare your results with my solution. Okay, so let's see how did you do to solve this example. We say 3875 divided by 16, because we want to convert it to base 16. It's 242, and the remainder is 3. 242 divided by 16 is 16. It's 15, and the remainder is 2. And of course, 15 is less than 16. So we get these values 15, 2, and 3. Okay, and this one is the result. So we we cannot show 15 as 15 in base 16 because we need to use our alphabetic symbols for representing base 16. So 15 is represented by letter F. So the answer will be F 2, 3. F 2, 3 in base 16. So 38, 75 in base 10 is equal to F23 in base 16. Okay. We want to check the answer. So let's check our answer to see if the answer is correct or not. Let's just convert this number from base 16 to base 10 with the method that we know by multiplying the coefficients by the power of 16. So here we will have 15, which is F, times 16 to the power of 2 plus 2 times 16 to the power of 1 plus 3 times 16 to the power of 0, which is equal to 3875 base 10. And our answer is confirmed. Okay. We have one example here to convert from base 2 to base 10. This one is from base 2 to base 10, not base 10 to base 2. So it's 0.10111 base 2. We want to convert it to base 10. Okay, how we can do that? With our method by multiplying the coefficient by power of the base. So we know that this one is this one. This coefficient should multiply by 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3, 2 to the power of minus 4, and 2 to the power of minus 5. Okay, let's do that. So it's 1 times 2 to the power of minus 1 plus 0 times 2 to the power of minus 2 plus 1 times 2 to the power of minus 3 plus 1 times 2 to the power of minus 4 plus 1 times 2 to the power of minus 5, which is equal to 1 times 2 to the power of minus 1 is 0.5, 0.5 plus 0 plus 0.125 plus 0.0625 plus 0.03125. If we add these numbers, the final answer will be 0.71875 base 10. Okay. So we converted the like a fraction part from base 2 to base 10. We should know that unlike the integer conversion, that always we have the exact like equivalent conversion of a fraction to a new base from one base to a new base, the fraction part. Do not always convert exactly. So and may just recover an infinite string of digits in the new base for complete conversion. So like a conversion is point two from one base to other base, which is base S. It might be like a point five, or it might be something point as infinity to it. Okay, so it might be like we cannot say that the fraction conversions always convert the exact values. Okay, so let's see some examples. But before that, let me just write it down so you can take a note. Unlike the integer conversions, conversion of a fraction to a new base do not always convert exactly. And may require an infinite string of digits in the new base for complete conversion. Okay, so this one is very important. Now, now that we learned how to convert an integer number from base 10 to other bases, let's just see how we can convert the fraction numbers in base 10 to other bases. For a fraction part, we use a method called multiplication. So with the integer part, as you see here, let me show it to you. Yeah, for multiplication, for integer part, we use division, but for fraction part, we use multiplication. Okay, let's see how does it work. Example, convert 0.1285 from base 10 to base 4. Okay, with the multiplication method, we simply multiply the number by the base. So 1285 multiplied by 4. The answer is 0.5140. Okay, so we ignore the integer part for the next multiplication, because for the next step we need to multiply the like the answer, which is 0.5140 by 4. So we ignore the integer part. If the integer part was 1, we still put 0 in the new multiplication. Okay, so we ignore the integer part, and this integer part is considered as coefficient a minus 1. So let's continue. Uh, this one, 0.5140 times 4 is 2.0560. Again, as I mentioned, we ignore these two for the next multiplication and consider 2 as these digits, these coefficients, and we continue with our multiplication 0, 5, 6 times 4. You see, we like ignored 2 in our next stage multiplication. If we multiply these numbers, the answer is 0.224. Again, we keep this integer part as a sub minus 3 and multiply 0.224 by 4. The answer is 0.8960. Again, keep this 0 as our result for a minus 4 and continue. 0.8960 times 4 is 3.5548, and we keep this 3 as a minus 5. And we see that if we continue this processes, we need to go forever. So it never like reaches to the end. So we stop at here and just keep our resolution as 5 digits. Okay, so we can continue this multiplication up to 10 digits, 20 digits, 100 digits, or infinity, but we never going to reach the end for some conversions. Some other conversions we may like reach to the end at like second digit. Okay, so now that we reached this point, we can write the answer. The answer is, we can say 1285 in base 10 is equal to point. We put this 0.0 because it's fraction part. And now we enter these coefficients as the result. So 0.0, now 0, 2, 0, 0, 3, and dot, dot, dot in base 4. So we converted this fraction part of the number from base 2 to from base 10 to base 4. So what if we have a number like a real number which has both fraction part and integer part? Okay, it's simple. We separate the fraction and integer part to two different numbers. For example, 25.5 in base 10. We say, okay, this one 25.5 in base 10, it's 25 in base 10 plus 0.5 in base 10. And then we do two conversions, the integer part with division method and the integer part with division method and the fraction part with multiplication method, and then add the answers to find the final result. Okay, so next example, I want you to again, as usual, pause your player and solve this problem yourself, and then compare your result with my solution. So point 0.29296875 in base 10, and we want to convert it to base 8. Okay, so pause your video and do it yourself, and then continue the video. Okay, so because the number is because the number is a fraction number, we need to solve it by multiplication. So I would say 0.029296875 multiplied by 8 is 0.234375. So we keep this 0 as a to the minus 1, a sub minus 1. And then we move to the next step, 0.234375 times 8. The answer is 1.875. Again, keep this 1 as a sub minus 2. And continue by with 0.875 times 8 is 7.000. We keep this 7 as a minus 3 and continue with 000. Okay, so we reach to the 000 if we multiply it by 8, so it's 0. So we stop at this point. When we reach to the fraction part of the 0, we done. So you see that for this example, we didn't have to go to infinity. Okay, we just got the answer, so we got the exact conversion. That's very good. So we got the exact conversion of this number in base 10, for base 8. So we can say that the number 0.029296875 in base 10 is equal to 0.017 in base 8, and that's it. So we got the final answer. Okay, one more example. Let's convert 13.375 from base 10 to base 2. So as I mentioned, we separate the fraction and integer parts. So first we convert the integer part. So the integer part, 13 divided by 2 is 6. A reminder is 0. 6 divided by 2 is 3. A reminder is 0. 13 divided by 6 is 13 divided by 2 is 6. A reminder is 1. Sorry. 6 divided by 2 is 3, and a reminder is 0. 3 divided by 2 is 1, and a reminder is 1. And 1 is less than 2. So we should keep this value in this direction. And we can say 13 in base 10 is equal to 1101 in base 2. Now the fraction part. 0.375. We use the multiplication method. We multiply it by 2 is 0.75. We keep this integer part. 0.75 multiplied by 2 is 1.5. We keep this 1. 0.5 times 2 is 1.00. We keep 0, and we stop here because we got 0 in the fraction part. So we can say 0.375 in base 10 is equal to 0.11 in base 2. Okay, and the final answer, we combine these two answers together, so we can say 13.375 in base 10 is equal to the integer part 1101.011 in base 2. And this one is the result. The next example, we want to convert 0.6 from base 10 to base 8. Okay, from base 10 to base 8. Point 6 multiplied by 8 is 4.8. We keep this 4 as a result. 0.8 times 8 is 6.4. We keep this 6 as a result, and 0.4 multiplied by 8 is 3.2. We keep this 3.2, sorry, 0.2 times 8 is 1.6. We keep this 1. 0.6 times 8 is 4.8, and we see that we are going back to like beginning, because now we need to multiply 0.6 6 by 8. So it goes back and repeat itself. So it goes back, it goes back, and repeat itself. So if we continue just be moving in this loop, okay? So we can say 0.6 in base 10 is equal to 0.4631, 4631, 4631, and up to infinity in base 8, okay? And also we can show it in this way, point 4, 6, 3, 1, like a bar. It means that just this term is repeating itself, okay? So 0.6 in base 10 is 0.4631, repeating in base 8. Okay, so we learned to convert some numbers. What if we want to convert a number from base m to base n? None of them are base 10. So from base 2 to base 5, what should we do? The answer is that we need to convert from base m to base 10 and from base 10 to base n, because we know how to convert a number from any base to base 10 and from base 10 to any other bases. So in order to convert, for example, a number 256 from base 7 to base 3, what should we do? We should first convert 256 from base 7 to base 10, and then from base 10 to base 3. Okay, so we converted from base 7 to base 10 by the multiplying with the power of 7, and from base 10 we can convert it to base 3 by division and multiplication method. Okay, so this one is the conversion between two the conversion between two uh, bases that none of them is in base, none of them is 10. Okay, but there is a shortcut to convert two numbers from two bases which are not 10. So there is a shortcut for some specific bases. There should be a condition and the relationship between these two bases which allows us to convert them directly without converting them to base 10 first. Okay, so let's learn it. So shortcut method of conversion for base alpha to the power of k. So there are two different possibilities. First, we want to convert from lower base to a higher base. So lower base to higher base. Okay. To convert a number n, a number and from base alpha to base beta, where beta is equal to alpha to the power of k. K is an integer number, okay, and positive. K is an integer and greater than 0. Group digits of n of n in base alpha into group of into group of k digits in both directions from radix. Then convert each group to base data. Okay, I will explain it. How does it work? Let me just tell you how to convert if we want to convert from higher base to lower base, and then I will show both of these methods in examples. B higher base to lower base. From higher base to lower base, what we do is like easy to convert n from base beta to base alpha where beta is equal to alpha to the power of k. Convert each digit in base beta, each digit in base beta to k digits in base alpha. Okay, so this one is like the way we convert numbers from base alpha to base beta and vice versa. If there is a relationship between them, somehow beta is equal to alpha to the power of k. Let's see in example. Okay, so here is like some conversion examples. We want to convert. We want to convert one 1 0 1 1 0 1 1 0 1 1 1 from base 2 to base 8. Okay, there is a relationship between 2 and 8. Okay, because we know that 8 is 8 is equal to 2 to the power of 3. Okay, so k is 3, k is 3, and beta is 8, and alpha is 2. In order to convert, because we're converting from lower base to higher base, we need to group the numbers in the groups of k, which is 3. Okay, so we group them in like this digit group of 3, 1, 2. We have only one digit for the last group, so we add zeros to the left of integer part. So we know that it doesn't change the value of a number. If you add like a 0 to the left of an integer number, nothing's gonna change. Okay, so 5 is equal to 0, 5. 5 is equal to 0, 0, 5. So we can add as many as we need zeros to the left of integer numbers. So we group them in the like group of 3, and for the fraction part, we do the same thing, one group, two groups, and we have just one digit left. So we add two zeros to the right of fraction part. Okay, so I said that we can add as many as we need zeros to the left of integer numbers. Yes, the same thing. We can add as many as we need zeros to the right of fraction number. So we know that 0.5 is equal to 0.50000. So we can add a zero to the right of fraction numbers. So we added two zeros to the right to make a group, and now that we group them, we need to write the values. So 001 has a value of 1, 011 has a value of 3, 011 has a value of 3, 101 has a value of 5, 10011 has a value of 3, and 100 has a value of 4. So this one is the equivalent of our number in base 8. So we converted the number from base 2 to base 8 without like converting it to base 10 first. Okay, so let's see. We want to convert this number a f point 16c from base 16 to base 2. Okay, please pause the video and do it yourself, then compare your result with my solution. Okay, uh, we want to convert AF point 16C from base 16 to base 2. So because we are converting from higher base to lower base, and of course we have this relationship between bases, we can use the shortcut method. If this relationship is not true in our for our bases, we cannot use shortcut method. So because k is equal to 4 for this example, we convert each number from higher base to 4 digits in lower base. So a is 10, which for binary number is 1011. F is 1111. Point 1 is 0001. 6 is 0110, and C is 1100. And so this number is the equivalent of AF point 16C in base 16 in base 2. Okay, that's enough for today. In the next lecture, I will continue with some more examples, and we continue the number system.